have a new module that we are going to make a project for making this a new project. This is MX1616H motor driver. So this is the IC of the MX1616H, and then there is a motor output. It is capable of connecting two motors, and for the input it has 4 inputs or control, and then we have the stabilizer capacitor for the circuit with a fast switching diode, a resistor, and this is the power supply. So we can able to connect a supply up to 12 volts. So this is the PCB. Let us connect a header so that we can connect the project or the control and the motor for the project. Okay, let us make the project. We are going to use this car robot that we have, and this motor driver will be mounted to the car robot in order to drive the two motors, gear motors, two gear motors, since our input or output is motor A, motor B, two motors for here, and then the control input, we are going to use this test push button to test the rotation of the wheels, and we are going to use this 18650 rechargeable battery in series. So it has 8.4 volts, since one battery is 4.2 volts. In series, 4.2 times 2, 8.4 volts for the power. So for the power, the battery, and then input, the switch for testing, and then the motor, two motors to the motor output. connecting the wires, the modules, the control, and the battery. We can now test the circuit by pressing the button. Button 1. Wheels is rotating counterclockwise. Button 2, clockwise. Button 3 for the other wheels, counterclockwise. Button 4, clockwise. Button 1, button 1 and button 4. Button 2 and button 3. In figure 1, we have the MX1616H motor driver pin out. That is the pin out of the IC motor driver. So you can see here, to the left side we have the input in which we connect the switch, and to the right the output wherein we connected the motor. And then we have this supply voltage of 8.4 volts from 18650 battery in series to 18650 battery. Then we have this capacitor, coupling capacitor, the coupling for the line stability or the circuit stability. And then we have this capacitor with the diode. This for to stabilize the power of the input side, this capacitor, while this capacitor for the whole circuit, to stabilize the whole circuit. Then we have this resistor for the biasing of the input. We now come to the circuit diagram of this motor driver while using the car robot. So in our project, this is the module, and then the switch is connected to the input. Switch 1, switch 2, switch 3, switch 4 to the positive of the battery. So this one is the power section, and then to the right side we have the output of the motor, positive, negative to the other output. Output 3, positive, negative to the other output. When we press the switch 1, it will rotate the motor clockwise. When we press the switch 2, counter clockwise. Press 3, clockwise. Press 4, counterclockwise. We can able to press both switch 1 and switch 3 clockwise, and switch 3 is clockwise. They will both rotate the motor. While pressing switch 1 and switch 2, it will stop the motor from rotating or moving, because switch 1 is for clockwise, switch 2 is for counter clockwise, counter. It will cancel the motion of the motor, so it will not rotate. Better combination is switch 1 and switch 3, switch 1 and switch 4, or switch 4, switch 2, switch 3, switch 2. So to the output of this motor driver, there is an H bridge composed of 4 MOSFET. This N MOSFET, then to the motor. This is the motor, and then it flows to the P channel type MOSFET. The first, this one, current flows into the positive direction, then to the P type MOSFET. The next one is the other set of H bridge is this one, another N type, and then the P type. While in the motor rotates, because the current flows from negative to the positive of the motor back to the out 1, from out 2 to the out 1. Here, from negative to the positive channel of the MOSFET. While negative, from this side to the positive, negative to positive of the, this is an H bridge configuration of using MOSFET. Again, this one from positive to negative, then from negative to positive by the use of this H bridge motor control, or this H bridge. So you can see my other videos related to this H bridge. And then this IC, inside the IC of this motor driver, since we are using the switch, inside the IC there is what we call the Smith trigger. Smith trigger switch is it will help to prevent the switch from false triggering, or to make the switch work properly, or to function the switch to make it efficient. Because if there's no Smith trigger switch into the input, it will produce a false triggering, because once we press the switch, there's a tendency to bounce the switch, or to bounce the signal if there's no Smith trigger. This is Smith trigger can eliminate the false triggering of the switch.